Welcome to my talk. Tonight, I'd like to talk about how I recently started a new project for C++ with CMake, and let's go. So at the beginning, I kind of first want to start with an overview on where I'm coming from with the project. Which starts with last year, basically learning CMake and looking at CMake generators to get projects off the ground fast, and watching some talks, and also this year watching some talks. So the talks are going to bring us from 2023 to 2024, and then we're going to talk about the actual project, which is a good part of the talk. I figured out that for newer projects, I should use CMake because it's the most relevant build system out there. And that's why I started learning CMake last year. And I went through the Learn CMake in 12 Easy chapters, like the official CMake tutorial on the CMake website, and played around a little bit with it. But I do not have plans to become a CMake expert. I want to write C++, not CMake. And I knew about CMake generators, and I kind of like that idea to have a generator generate the currently good CMake you should use. And then you can, improve that or build up on it. And so let's see if that is actually a working idea. So what I've been looking at last year is the CMake starter template from Jason Turner and the CMake init CMake generator on GitHub from Friendly Anon. And my impression with the CMake starter template was that for someone who just learned CMake, it's such a strong and steep learning curve. You get yes, the perfect GitHub setup is really cool to have, but I wasn't looking for a project which has all those bells and whistles already running, and if something is not passing, you get emails because an action failed, and then you get another email because another action failed. It offers fast testing, which is really nice. It has CPM, which is a package manager for CMake integration, which is really cool. And Jason Turner did some videos on this last year. So just by looking at this, you have lots to learn. And the GitHub setup wizard is then basically running, and then you get your own copy of this into your repository on GitHub. And if you read the last sentence, this project gets you started with a simple example of using FTX UI, which happens to be also a game. So this is what you get. This is kind of nice. It's an application, and it's good for probably to get started, to get running, to have working C++ code in a good setup. But I actually was looking for writing a library and not an application, and I don't need FTX UI, and I now have to see to basically get rid of FTX UI again, and have to do a lot of other setup things to get this down to the bare bone thing I would like to have. And I'd like to have more like a modular thing where the GitHub wizard asks me more things, what I need, what I want, and then integrates that. And this kind of is a bit the idea of CMake init, which is a very nice project on GitHub, but you also can install it via pip. It's a project generator which lets you create projects for executables / applications, libraries. It does have support for Conan or VC package. It does not have a CPM integration right now. That would be nice to have. and it has like some other things which you can do just when you look at this tomorrow at GitHub or later. That's generally something nice to look at. I've played already last year with the .37 version around, and now the .40 version. And since February, beginning of February when I did this, there is 3 minor versions released. So this is like really in maintenance, this project, and under development. Regarding the package managers, I do not know. I suppose that Conan is a Conan 2.0 support, because that's something new, I think, which has been added. But I'm not sure about that. So I do not have a project with Conan support generated by this at the moment. I might give that a try. I know VC package exists, but I personally have a preference for Conan. So if you compare them, one thing I wanted to point out is actually CMake init is a command line program. It generates locally something on your system, and it's not automatically giving you a project setup with GitHub. If you're looking for that, CMake template from Jason Turner will be better to automatically give you all the other setups and tools which you probably should or want to use, or you would like to see a working example of those. So it's really great work and really well-maintained work by Jason Turner. Thank you for that. And CMake init fills a bit of a different niche, which can help you a lot in getting started. And that's what I've been using to do last year. But then I was getting busy with the conference again. And so I didn't really have the time to have like really enough time to start a new project and all the other things. In the retrospect, I'm happy because I can now use GCC 13, and back then I was based on GCC 11 because it was available back then to install on the system without compilation. And so right now I'm building the application with GCC 13, which is a lot better with C++ 20 and C++ 23 support. Like, for example, today I found out that I actually, if I wanted to use STD expected, I could. So let's talk about talks. I was really looking forward to the talk from Mikhail about how to start a modern C++ project at Mini C++ last year, and I had the privilege to see this talk. I think we pre-recorded it twice, so it's kind of a good talk which covers a lot of other angles. It covers a lot more of CMake. I'm not the person to teach you CMake, so I'm not going to go into the newest stuff with CMake or the older stuff or how you should do this. I think that it's great to have generators. I like generators. That's more my thing. And he goes through a lot of other technologies and stuff, and so that's a great addition. He points to the CMake plus Conan 3 years later talk. Unfortunately, that predates Conan 2.0, I think, but it's by Matej Puls, also great speaker, and good info on how the setup with CMake and Conan is. And I guess a lot of what he talks about is still true with Conan 2.0, but if you're interested in that, I'll have a talk on that later too. And last weekend, I saw that also, like, start your C++ project today was a talk at the C++ Serbia user group by Dusan. And I've watched this talk, and it's, again, very different to this talk. This is also going a lot into technologies, programs, and tools you can and should use for your projects. So this talk is a good talk to skim through, to watch if you have the time. He goes a bit through Bazel, a bit through CMake. It's kind of everything is being touched on. And then let me go to CMake again. We have a complete talk on CMake and Conan next week with Diego Rodriguez Lozada, talking about CMake and Conan past, present, and future. And we're gonna see the recording with him, so you basically can watch the talk in a group setting with everyone else and watch the chat with people, have your questions directly answered by the expert. Really looking forward to that. It's next week's watch party. The first watch party a few weeks ago was with Phil Nash. Worked very well. And so next week we're going to learn more about modern CMake, putting projects up running with Conan and how this works. With the weekend, there has become 2 other talks from Meeting C++ about CMake Popular. These are both from Denis Bahadir, which, more modern CMake, and more modern CMake is 2 talks which he has given in 2018, 2019. And these talks got popular by being in the answer to a question at r/cpp and on Reddit. So 2 people have said, this is CMake. If you want to learn CMake, watch those talks. So I can agree with that you should watch those talks. And there's more talks. And the reason I'm not giving a CMake talk is just that's not my part of what I'm about, right? And there's a lot of other content on it, and newer talks on CMake probably exist, and we will hopefully see more CMake talks this year. So if you want to give a CMake talk, it would be great to have another CMake talk this year at the conference. Or at CPPCon, definitely also will feature one, I think. And then, of course, I just quickly want to give a shout out to the Learn Qt Guide channel on YouTube. They have a CMake series where you can watch many episodes where things get covered in depth about how to start and work with CMake. And I'm probably also going to watch some of those videos when I have to edit the generated CMake. Which I felt much more confident in doing with CMake init generated code for CMake than the Jason Turner version. Also, by researching some stuff for CMake, I found this tutorial, which actually is from last year. So it should cover more recent CMake. And there's, of course, a ton of other CMake tutorials online. Choose the way you want to learn CMake and how much you want to CMake in learning. I, for one, wanted to see in this year what's, for me, the best way to actually have the whole setup for CMake for various projects be generated and then having it connected with my IDE, which is Qt Creator. So I finally had the time in January to pick this up. And my first thought was the one thing I didn't test last year was the IDE. I maybe missed that Qt Creator is up to speed and can generate CMake projects in the same way or in a compatible way. And maybe it would be just as good to use just Qt Creator and I'd be done, right? One shop, one stop, and done. So my project is a CSV chart tool, and I first want to start working on the CSV chart lib, which is this talk about, and then later generate also the application and a CSV chart Qt library. The Qt creator created a library project, which is something I was aware about Qt creator having this. And then I added in this directory project a CMake library project, which Qt creator lets me do. In the aftermath, I figured out that the directory project is CMake based, and then I have just a CMake project in the directory, which is kind of fine. But looking through the CMake code which came from this, I was like, that's probably not what I want. It's completely working CMake code, which includes Qt, which is nice and helpful to have for future projects, where I probably will have to implement that. But the CMake itself was for me too simple, because I wanted a different setup, and this is basically most of the CMake which got generated. I would like to have at least a CMake project which not only includes building the library, but also includes building an executable, which is the tests. And I already knew that CMake init can do that. So my first attempt was just give me your defaults, right? That's the other thing which you probably see here. The standard, you'd have to change that. It's here at 17. That's how Qt Creator got this generated. Fine with me, but I'd like to use C++ 20 at least. So this is how I generated it for the first time. The result of that was that it's actually too noisy. Clang tidy is picked up by Qt Creator, and Qt Creator starts checking like everything, and you get everywhere Google style guide, and I'm like, that's not how I want to live. So my second attempt was basically, for now, doing away with Clang tidy, because Qt Creator has its own Clang tidy. Qt Creator does Clang tidy in a different way. So, and at the same time, I don't have CPP check installed at the machine which I'm working with this. So I was like, okay, just don't need that setup at the moment. Can toy around with it later. The examples I left in, but in the meantime, I'm not sure. Like, I'm probably going to leave that empty and remove it later, maybe, but removing it would be an effort. This is an internal library, and it's not like a library where I want to actually provide examples on how to use it. So what I like is the test is basically the default executable in Qt Creator, and Catch other frameworks need to be added if you don't use a package manager. Otherwise, Catch 2 is automatically installed in your project, which I like. One issue with Qt Creator at the beginning was that I only got the source folder with the CPP files, and the include folder, that doesn't show up in the tree. You can have it show up if you then add those files to the CMake txt file again, which I did, and then it works and it still builds, so I guess it's okay. And in earlier versions of Qt Creator, I always had like the issue that I needed to build the library first and then the executable. And here it's like really nice to see that basically I changed something in the library. It compiles, links the tests, and runs the tests, and lets me know if my change was correct or not. And my only issue with the test executable, or generally with this project right now, which I have to dive into when I have time for that, when it really bugs me enough, is like at the moment in Qt Creator, I can only do debug builds. Normally, I should be able to do a release build, but that doesn't show up. So I guess I need to add a kit for that or something. I need to understand a bit more of this corner with kits and CMake and presets and that stuff. But that's stuff which I want to look at when I need it. So now that the setup is there, I think it's time to go into the C++ code and write the library and see how this builds, how it behaves, how the tests run. At the beginning, I want to compare this new approach with CMake versus the old approach, which was based on Qt and CMake usually. Now I try to start with the library only, which has an executable for unit tests. I focus on standard C++ and try to implement the basics. Maybe I add some libraries which I need, maybe I don't. And I add later the Qt library tests and a front end. I usually try to keep the pure C++ standard stuff in a separate library for licensing purposes, so that this code is not like LGPL as Qt is LGPL. And in the past, I often kind of, started the Qt project, which is a UI executable, and I focused on features and progress. I always have separated Qt and standard C++ code if possible. But I rarely have put that in libraries or like have this actually more bundled like I can do now. There is no CMake generator for projects. Qt itself generates via Qt Creator basic projects, but already like testing is in this not covered. And with other IDEs, I don't know if they like generate projects with tests for libraries in the modern age. Oh, that's still like lacking, which is probably one of the reasons why so many things are not in the state where they should be with testing. But that's a whole completely different topic. So the project architecture I have in mind is like have the UI executable, which is the main program. It will handle some part of the parallelism, but that's like a whole thing I'm not going to talk in this talk about. And basically plug together the application. And for the charting, I'm going to use KD chart as the plan, which probably already also will be part of the library, which the Qt app library, which contains, for example, models, the panels, a lot of the glue code to connect to the standard C++ code. And the CSV chartlib is basically what's currently implemented. It's standard C++ code for loading and searching in a CSV file. And then the next step is probably to add the Qt app library and see that this is kind of, playing nice, that I can then quickly add the executable and then really have like this all being linked together and running and into an actual application. So the current version of this chartlib is what I've written, and I've already made a lot of changes for preparing this talk, and some of my tests and some of when you go bottom up, you find out that some of the classes which you implement on top have a certain need for some functions which you didn't implement yet, and so you need to provide some services from your lower classes to the upper classes. And I thought I'd start with a class overview. This is at the top, I have a document class, which goes into having a container of data sources, which then have a vector of records. And the record holds a vector of string view value classes, which represent the values that are in a string view in the record. Okay. And then I have completely different search condition classes: value, value range, value list, and unique at the moment. Value kind of a self-explanatory, and value range is basically, I think the only one I really have to explain is unique. Is a bit misnamed at the moment. It has an internal container and only counts the first occurrence of a value as counting. And I probably should like rename it to first unique or something. Then I have a condition list, which has an enum for being and or, and this then gets bound together in a variant to be the search tree, which is part of the searcher class. And then you have the record holder, which later will be again forming a transform which leads to the graph. At the beginning, I thought that the searcher would basically return the graph, but then I realized that I need to be able to cache the search result and not automatically transform it in the end result, because maybe I want to have multiple graphs from the same search. And especially like when I want to display the result of a search in a graph, but also in a map, I should not destroy what the record holder has. And the graph transform basically, the data you need for a graph is not what the records hold. The records hold a date, and the graph transform is based on a month, right? So you will completely be different there. And this will be very complex to implement, and many graphs will have their own specific classes. So that's something which I will have to deal with later. At the moment, that is like I have a few toy implementations for this, which help me test this, but then later I will have to see how this fits into the overall application later. And then I have a CRTP-based class, which is kind of linking value range, etc. together, also conditionless, and allows me to build this tree in a variant, actually. Which brings me to the first class. Which is string view value. String view value has a string view into the raw data, and then has a variant of basic types and std any. Any is for the case that a user supplies its own conversion for a field. And as any can be anything, this needs to be completely its own support. And this basic value variant, which is those basic types, at the moment is string view, bool, int, long int, size t, float, double, chronosys seconds, and std any. I'm currently thinking about also using struct tm. I don't support timestamps in the moment, but I could with chronosys seconds, where I better keep it. But struct tm already has like all this data which you want to query potentially. While chrono lets you easily do calculations with dates, I think in our context, in this context, struct tm might be the better choice to basically have this all there in memory. But struct tm, of course, is a lot bigger than this variant at the moment, so I'm not sure about that. And then I have an enum which holds the indexes of those converted types, so I can basically query the index function of the variant to see if that index is currently the index and compare against it. I have a conversion function which returns this type currently, but when I started thinking about multi-threading, it occurred to me that error handler probably will be, so error handler is a class which is, you're going to see a lot. This is the first time you see it. Maybe you should talk about this first. Error handler is just a templated way of dealing with errors and forwarding and logging conversion errors, especially here. And in a multi-threaded conversion, you would not be able to know of your error handler basically if that conversion has now happened to be erroneous or not. So this should be an optional, or with C++23 expected would be something, but I think I would like to keep error handler around so that basically you write your own error handler, which is also kind of not defined right now. I have a class which basically is the interface to this at the moment. And then we basically do all the conversions. If it's a string view, I don't need to do a conversion. I can just return raw data, right? And if the type is already in the index, I can just use std_get and return that. If that's not the case, I need to do a conversion, and with bool, I kind of do it like that at the moment, which I'm happy with. There's probably like still some improvements in this code to be had, but for the moment I'm happy with that. And also, I do not have the use case that I actually need a bool conversion at the moment, I think. I do use a lot from chars, and today also saw that there is already a conversion function in C++ 11, and then I think 14 or 17 added from chars. And one of the interesting differences is that from chars does not eat leading spaces. So if this field has a leading space, the conversion will fail here. But if I then tried the C++ 11, I think it's str to D and str to F and str to L version, this would then maybe convert it. So I'm wondering if that's worth writing another conversion if this conversion fails. And if the conversion fails, that's basically where I saw that's like from chars I get this error code, and then I would like to be able to log that somewhere and to keep this error message basically be constructed here locally, that it makes sense in the context. When I convert this to std expected, I'd have to see if I still need error handler or if std expected can take care of this, and then the error handler does not need to be brought in everywhere, or how this basically then would look with std expected is an interesting question for me in the moment. Chrono needs extra handling. The basic parsing from string to date is well supported if you know your format. But basically you're getting a CSV which can have everything. And so Qt has some interesting functions where various text date formats are covered. And I probably have to, figure out how to implement that with here and then try to parse them all and see if one of them catched on. And this whole string is for the format string here. I feel it's like a difficult user interface. Chronoparse was not a level in GCC 11, so I was not being able to use it. As I mentioned earlier, now I'm on GCC 13, and I still have to look up if it's available. But for the moment, that is the code. Unfortunately, also with Chronoparse, I would have to use a string stream. And the string stream at the moment, I think, is not able, at least I couldn't find how to use a string view. So I have to put this in a string. And if the string is, not having SSO enabled by the smallness of this raw data string view, we'll have an allocation here, which is sad. Then we read this into a TM struct. That's also kind of why I'm thinking that we might just put this into the variant and call it a day. Then we create from that the time t, And the time t actually you can then convert to chronoseconds with a time point cast from the system clock, and then you're good to go. I've recently looked into one of the use cases I have, and it came to my mind that I overlooked that a date time could be a date and a time. And so that CSV file has a date and the time in two different fields. And I don't want to provide the functionality to join that together. I might do that later, but for now, I at least want to see that if I can parse this. And at least for Chrono, it's like that you can parse the date, but Chrono does not have a default type for something that is actually just a time without a date. That can be done, but you would have to implement that and search that for yourself. There's some interesting comments from Howard Hinnett on various online platforms about that. And actually, the test case I had, when I got this working, this is a test case, and unfortunately, this test case fails, which kind of surprised me, because this is basically code which I parsed the date with earlier, and now I parse the date time with earlier in the test case, and then I copied it to parse only the date, and it fails. And I just, I remove the output I had here for debugging purposes. This is the line, and the reason this fails is here with floor. Then you get to have the year, month, date to be April 15th. And I assume that has something to do with that we do not generate a time here, and then it's using the system clock or something. I'm not sure about where this is coming from, but if we use round, it works. I've been looking at where did I get this, and I was like, oh, this must be CPP reference, and I was like, oh, this is also is this correct for the example code? And with this run this code on this run this code button on CPP reference, you can actually run the examples there, which is very cool. And if you add here round, this is actually then wrong. So you need the floor when you parse the date time. And that led for me to the question, does this actually parse other dates correctly now, or does it work for the date I picked? So one thing I like to do in my tests now is to write a lambda, which gets the parameters I want to test. And in this case, I use STD format to format this into a string. And I need to do this because I need to compare against those integers later to see if the parsing with Chrono has been correct or not. Otherwise, I could just give it a string view. But if I give it a string view, I have no idea what these are. And I found it interesting that Chrono year is an integer, which years can be negative, but month and days cannot be negative. So they're unsigned. Which brings me back to the string view value class. I provide also a conversion function where you get already an optional to see if a field has been converted. the search condition classes convert and the search transform classes access the fields. But it also now occurred to me that the transform also will have to access fields that have not been converted to an integer. And the classic example is like counting fields. I have like a field which tells me how many things are in this line. And like, for example, those ticket sales as a CSV file, and you get the number of tickets. You're not going to search on this usually. You maybe search on the date to know the sales from a month, and then display that in various things maybe. But the counting field might be interesting to you in the transform when you want to display how many tickets you sold in a month. The other thing is that not all of the transforms will have to do this. Sometimes you just want to access the field and basically count it like a counter, not like a sum. And then you may want to convert it to check for correctness, or just accept that it's there and just say +1, yay. And this function is very similar to the previous function, so I'm not going to spend a lot of time on this. This brings me to the record class. It's basically a vector of string view values, and I have a string view for the line here, which I'm currently not using, but if I ever need it, it's there. I have two main methods here. The one is for accessing a record of the string view value, and then there's a condition check which gets a CRTP base class for conditions, and the error handler. And some conditions will not have a way, or will not need to access an index or like an actual value in the record. They will have to check the record itself. So I need to see if if this visitor has an interest in the index itself, and if it does not have it, then it just for example, the condition list will just need to have the record, and then call this function again with all its search conditions in its vector. Which already brings me to data source. The data source class contains the string which contains the actual file. That has a vector for the headers in a string view, a map of the field names to the index, and a vector of the records. And something I didn't add here, recent changed, I saw that at least from the point of view of the application, I should also have a vector of unique values per field. So I currently have this in the data source because it makes sense to generate this once and then basically have this available. The search records is just, coding things and counting things and returning them at the moment. The interesting part is to create this class in its factory function. It gets a file system path and then creates it and returns this. So we read the file into an if stream, push this in a string stream, and then retrieves the string from the stream, and this is basically what this is based on then. We have a sync lambda which gets the line and the fields, and then basically calls mplace back. And I think I should move the vector then into the records. Parse CSV at the beginning when I started those slides still had the comma hard-coded. Now there is a find delimiter function which gets the actual data. I check for comma as a default delimiter, and for the semicolon, also kind of check for the position of the first line. And this might have to be, improved with some error checking, that, we shouldn't do this on like an empty line or something. But at the moment, I think that is like the user's fault then. And the parse CSV function reads the headers and the actual lines with the parse line function, and then just generates the various data members which it has received via reference. The parse line function is basically an adoption of the code I wrote last year, but I need to handle quotes with new lines in them, and that's basically what I added. That's just another mode, and I've given like multiple talks on parsing CSVs last year, so this is covered, and not that interesting. Which brings me to document, which binds this all together, and logging handler is the current error handler implementation. I use reference wrapper here to replace it and basically have a default handler. I'm currently thinking that it makes more sense to have the document class be a template and have this error handler be the template parameter that the outside can provide its own error handler, instead of having this hard-coded here. So that's probably a change which is coming up. Then I have various functions to manage this. I have an add function to get the CSV loaded. I can remove the data source. I can visit the various data sources the document has loaded. And I have often a size function to return the size of the container for testing purposes, and probably later in the application this also will be useful. And that are the methods for handling data sources, and basically I have the same thing for handling the searches. I've moved the name of the search into the document, and the name for the search is not needed for the search class itself, and basically is something which needs to be attached from the application to handle searches, right? To display this. And I'm at the moment not sure like how I do want to do this and what's the best design for this. Where to put the name? Should it have a name? Should the library which is focused on the application handle this? These are kind of the design questions which I'm thinking about sometimes. Which brings me to the CRTP base class. Quickly, let me look into the chat. Someone asked if I have thought about implementing a pure C++ solution for demo purposes. No, I have not. I don't have the time for that. I don't want to add a database, and I don't want to cache the CSV file content in an SQLite database. That's completely not the route I want to go, okay? So there's a question on LinkedIn. I do not have the library currently on GitHub. I probably will do that later when it's a bit more cleaned up and I'm more certain about the implementation. But at the moment, I don't want to have people basically trying to, send me their PRs and something on GitHub when the thing is not done and ready. And I do work on an application here, and so the library is not the main focus. And I'll be soon busy again with running stuff for the conference, because the conference will be announced in April. So let's go on. Let's talk a bit about CRTP. I kind of have the feeling that this would be a good way to implement the hierarchy for the searchers. And so I've looked around to read up on CRTP again, and there's a 3-part series at Fluent C++, which covers a lot of the things which you will see now. I know that C++23 also has something about CRTP, but at the moment I do not use C++23, so this will not be part of this. Maybe I add this later. So this is the basic class which I have. Class derived, which is then declared a friend. And this base class is for all search conditions the base class. And private are the basic constructors to construct the base class. I then learned from the tutorial at Fluent C++ that you should have a method which is to-derived to basically not have to write static cast everywhere. And in constant methods, you would have to write constant static cast, constant derived and derived. And this way you get around this. This way you just call derived and you're done. And in this case, we need to the two methods which are currently implemented are check and check record, and name is the example which Fluent C++ has. And I think when I add serialization, that I can basically save a document with its searches, that might be useful to basically have a general name. And another thing which would make sense is basically to have like the type ID be returned here, which I guess you already could do in the base class, right? You have the derived type, and you could get the type ID and you could return the type ID, and so that you don't need to implement that. And the type ID would be a non-human readable name of the class. And in that way, derived as a friend and can construct its parent and no one else. I wasn't sure about how things play out, and so I have at the moment I'm not sure about the move in the copy constructor at the moment. It's there. Probably will delete it and see if it still compiles as I have tests and see if it works as private. I do like to, when we talk about construction details here, I do like to declare these as default. Because I think it's often better to have this explicitly declared as default than to just not have it there, or to implement it yourself, which you really shouldn't do. Let's go over value range as an implementation. So here we see basically how I check if an error has occurred currently. I get the log size, and I see if the log size is still the same when we converted this. And when I looked at this code and thought about error handling, I began to understood that this is basically this code will give you trouble in a multi-threaded environment, because between reading log size and reading log size again, someone else can have converted an erroneous type somewhere else. And then you do not return and you do not convert this part, which has been converted successful. So I do need to return the type as an optional, and then I have this encoded in the return value. And yeah, so lots of that stuff is also new to me. Optional is a nice thing to have, and I see that it's in a lot of places of things which return things. It's a good thing to have. Then I need to have a variant which is basically a templated using declaration on all those condition types I have, which is the downside of having it like that. But that way, we then can construct the variant which holds a condition. And so we forward declare the class condition list and declare search value types with string view and all other types and the condition list. And then the search value variant is in the condition list class. There is an enum for and or, and a mode for which is by default and, because basically the searcher has a variable of this, and by default it should be and. That's a good user interface. And if you add a search condition list to a condition list, then you have a tree. Which brings me to the searching part itself. So here you see that the searcher had a name, but this got moved, and I'm not sure if I'm moving it further. But basically, the searcher needs to have the condition list and the records of what has been the result. And I have an add condition function, but of course I should also have a remove condition function, which I need to still implement. I did this for the document, but it's like something which I need to do here too. And then basically I have the search record function, which just takes a record, calls check record, calls add record if it's true, and returns true, otherwise it returns false. A lot of those implementations are very easy to write now. The transform search result is another thing which I'm now more sure about, but I really had to try to figure this out for a week and to look into what actually my, this is not inside the library. The library does not provide the graph format. There's a graphing library I want to use, and this is basically what's supposed to go in there. So I'm kind of implementing something which I have to look up, what that is at the moment. And the transform has access to the full record. And as I mentioned, might need to convert the field from a string view to a sum or any other things, because they were not touched in the actual use case for the search. The record holder in the moment does not copy the record, as the record itself uses a string view, so copying the record doesn't really make sense. So I put that in a reference wrapper, and then basically every record gets added to this. And I provide some iterator interfaces that this is easily accessible for each loop. And it's just a simple class to cache the search result. The transformation, as I already mentioned, is a lot more difficult. In the end, the graphs are often number-based, and I have to figure out what are the things that is needed to be generated from this transform. Is it like one thing, or is it multiple things? And how do I want to design this in the future? And the whole thing is just, sometimes, of course, you could just want to display the search result, which is probably something which I do, that you can see the search result, which is also for debugging purposes when you debug this, or actually want to see what are the records which the graph is based on. Does it make sense? Or do I have to add another search condition? So I definitely also plan to have like a table view which displays the records. And then there's the whole topic of grouping. You have group on a column type. That's easy per month or year. So I have some functions which basically return a string of a year, month, or something to group against, or an int. That's stuff of the future. I did a lot of dummy transforms and thought, can I, kind of write some central things, which is like the architecture of that, and I reuse this architecture. I have not come up with something which is reusable at the moment. From Qt perspective, this will need to be held by a class which is a front end to the model view architecture. And then there's also like an easier way to do this, to basically have a Q vector be filled with the data, and then that is like one line or one row of bars in a chart data class, which you add to the graph. But this is basically something which I need to start implementing when I know what Qt needs and can test this against Qt. And I have used model view in Qt quite extensively, so this is easy to implement. Copying your data in a Q vector is then also a needed thing from the Qt interface, and I have to see when to use one and when to use the other. Already mentioned I want to use KD chart for this, which is a very nice library from KDAB. It's MIT licensed, so when you have a commercial Qt license, you can use it. When you have an LGPL open source Qt version, the LGPL stays. It has very advanced charts also, and it has a 159-page manual, which I've been partly reading through, but not completely. I have many open questions, and this will be a lot of fun for me to implement that in this and probably the coming year. And the next thing to do is basically to write the application library, which uses Qt things and provides tests for stuff which the application uses, and then to have a CSV chart application which combines them. But also, I'm getting busy again. I have to still, do a lot of stuff for the conference and get things ready. So I guess I will return to this in summer, and maybe, some of the open questions I'm currently thinking about. Maybe I, do some of the refactoring for the multi-threaded code, which I see that is like a requirement. That would be interesting. So thank you for your attention. If you have any questions, please post them now in the Q&A section or in the chat, and I will try to answer them. Thank you much. Yeah, I see someone commenting that CRTP is deducing this, and I've heard about that, but I need to look into this, and I do not have GCC 14 at the moment, and so actually being able to use deducing this would be really nice, but I think that at the moment I'm gonna shy away from doing that. That's just, I'm based on GCC 13, and I'm probably for the next year going to write code based on that, and then hopefully be able to go into GCC 14 and other adventures. And as I mentioned, this is currently not on GitHub, but I have plans to add this later, and will do so probably within the year when the whole code is cleaned up. And at some point, I have to add it to GitHub anyways to have it, basically pulled down to other build platforms and have it on my notebook that I can take it with me and code in my holiday on it. And I see that Paolo is mentioning that if you need an educational license and you're a student or like, a teacher, you can get that from C-Line for JetBrains. And yeah, GCC 14 has not been released yet, and so I think that deducing this in C++23 is very interesting. But I also wait for ISO to release C++23. So at the moment, I tried to learn C++20, and I saw that I like STD expected I could use because it's in 13, but I don't know if it's like worth dragging in a feature like that already, and not like have people wait for it and gain experience with it. I'm not an early mover with my code. Okay, so if there's no more questions, I think we reached the end of the talk. Thank you for coming. Thank you for sticking around. And